Bill Gates' energy company, called Breakthrough Energy, has been doing projects that speed up innovation in sustainable energy and reduce greenhouse gas emissions. His company's most recent project was suggested by Sandeep Nijhawan, who wanted to clean up the steel industry. BEV investors took an interest in his project, and work has now begun. To know more details, keep watching. Up first, Nijhawan's pitch. Sandeep Nijhawan met up with an investor at Breakthrough Energy Ventures BEV, Dave Danielson, in 2020. He had 4 business ideas, all of which addressed rising global temperatures, but he only got around to talking about the first one. The idea he presented was to make iron without coal, intense heat, or emission, something that would be powered only by renewable electricity. Before Sandeep could even tell the rest of his ideas, he was stopped by Danielson. The investor told Nijhawan that this is what he wants to do, and doesn't want to listen to the next 3 ideas. Moving forward, the impact of the idea. It's understandable why Dave was interested in going forward with this idea. It was reported that iron makes up about 98% of the substance in steel. Steel is used in infrastructure, tools, trains, buildings, ships, cars, and many other objects. While we know it is used in many objects that we use in our daily lives, what isn't common knowledge is that producing steel releases huge amounts of carbon dioxide when it is heated on coal at 2,500 degrees Fahrenheit. That being said, it was reported that steel production accounts for 7% of greenhouse gas emissions that are dumped into the air annually. To put into context, that number is much more than the combined climate impact of aviation and shipping. That's why Sandeep's idea caught Dave's attention. Producing affordable, inexperienced steel is a big deal, which will disrupt an industry that generates more than $870 billion in revenues each year. Aside from other investors, BEV invested $2.25 million in Nijhawan's Electra. Moving forward, the 3 methods to reduce emissions from steelmaking. Most startups begin their experiments in a storage area, and Electra was no different. Kwok Pham, Nijhawan's former colleague, joined as a chief expertise officer for the project, and his first job was to determine whether there was potential to dissolve iron ore in water laced with acid. They were met with failure. Pham informed Nijhawan about the bad news and stated that this could be the shortest startup of his life. To understand what went wrong, let's dive into the 3 methods that were tried to reduce emissions from steelmaking. First, a plant was built in 2016 in the United Arab Emirates, but thanks largely to the upfront expense of carbon capture expertise, there has been no construction of 3 plants since. The second method was to use hydrogen as a substitute for coal. The first cargo of steel came about last year, which was made by utilizing hydrogen, but the business volumes couldn't be obtainable till 2016. And since the hydrogen produced from renewable electric energy is still more expensive than coal, companies and firms are pressured to use high-grade iron ore. Unfortunately, it was reported that there isn't a lot of iron ore left, which was another hurdle they must overcome. Third, the usage of electrical energy. Different metals like copper, zinc, and aluminum are formed by utilizing electrical energy. These metals use less energy than in the manufacturing process of iron. Until the electrical energy grew to be low cost, it wasn't considered economical to use it for iron manufacturing. Next up, Boston Metals Company's solution. It was discovered that electrical energy can't be moved by cast iron ore, but one startup could find a solution to soften it. Founded in 2012, the Boston Metals Company had been working for the past 10 years to perfect and scale its expertise, which worked by heating iron ore to 1400 degrees Celsius by using enough electricity to supply thousands of properties. It also concentrated it right into a steel area which wasn't a lot bigger than a dumpster. A lot of electrical energy can be concentrated in small spaces, but only by using specific supplies. Boston Metal could get it by utilizing carbon as an electrode, but that too had its side effects. One of them being that it generates carbon dioxide, which then defeats the aim of utilizing electrical energy. While the company could find other metals made up of iron and chromium, at this point it works on a pilot scale. Now let's talk about Nijhawan's struggle. Unlike Boston Metal, Sandeep didn't need to soften something while he had a course of working at molten metal temperatures, which have to be 24 hours. If it ceases, the ore ends up solidifying, and new vats must then be put into place, which then causes months of delay. According to Nijhawan, the course had to begin from the perspective of the temperature, which according to him was not hotter than the temperature at which coffee is brewed. But working at such a low temperature required Pham to dissolve iron in water laced with acid. Sandeep explained that his pitch to the investors was that he didn't know if all of this can be done or not, but he believed there was a workable path. He explained to them that all he needs is less than 10 people and maybe a year or a year and a half for this project to run. Luckily, he didn't have to wait that long. Pham learned the scientific method and consulted specialists together with Dan Steingart, professor of chemical metallurgy at the University of Columbia. After weeks of new experiments, they could discover a profitable solution. Coming up, current-day Electra. Now, Electra is entering stealth mode, and it refuses to talk about what they have planned for the future. But Nijhawan and Pham have shared sufficient possibilities for impartial specialists to affirm that what they plan on doing in the future is possible. Affiliate professor at Carnegie Mellon University, Venkat Viswanathan, talked about the firm and stated that they have pulled off a difficult conversation going from iron oxide to iron by only using electricity at low temperatures. He explained the steps they take to alter iron to be in the state that is perfect for them to work with. The firm's Colorado facility also highlights its progress. A tour of the facility revealed that there's no coal-fired furnace or molten steel, and the lab demonstrations present how the iron ore might be dissolved. After its electrical course is run, Electra produces plates that measure the production with a thick layer of iron steel on them, which has a silvery gray finish that is heavy. These experiments have been successful and have helped Electra elevate $85 million from BEV, BHP Group, Amazon Incorporated, Singapore-based fund Temasek Holdings, and some other buyers. The next step for them is to scale up their expertise. That being said, what does the future hold for Electra? Since they have been successful in their experiments, it's exciting to see what the firm has planned for the future. So far, they have promised to construct a facility that can have several commercial-sized iron plates. After that, they plan on making thousands of plates in a bigger manufacturing facility. But with all that being said, it looks like they already have some strong competition. It was revealed that Boston Metal has promised to produce emissions-free iron by 2026, and so has Swedish steel firm Saab, who stated that they want to make commercial quantities of carbon-free steel by 2026. It was said that a full-size business Electra plant might be a lot smaller than standard steel vegetation. This might generate 2 million metric tons of steel per year, with a value being greater than $1 billion. The company revealed that they will look to construct vegetation that will produce 300,000 tons of steel, a measurement that will enable the startup to place itself closer to the present electrical arc furnaces. These furnaces take scrap steel and recycle it, and may also use the iron that the company produces and tweak the mixture to make clean iron scraps of steel. Wrapping it up with more details on Electra. Another advantage might be that the Electra vegetation shuts iron ore mines that are positioned away from city facilities and close to a place where renewable energy can be constructed. Electra vegetation may then turn ore into iron ore on the site, eliminating all impurities, which will decrease the quantity of fabric that is to be transported to a steel plant. There's also a chance that the company might begin its first business software in coming up with a way to dissolve iron ore. Electra took away impurities in a contrasting way to standard steelmaking. At low temperatures, the impurities don't react as they would in a furnace at 1600 degrees Celsius. The world is sitting on billions of tons of low-grade iron ore. There could be potential for Electra to construct factories to shut down mines and make present operations more economically viable. Talking about the startup, Nijhawan stated they don't have 10 years to develop a new science, and time is of the essence in a startup. He stated that the pressure is real, since you don't have unlimited time and resources available. You need to work and discover distinct possibilities. That's a wrap for this video. What do you think about the new Bill Gates-backed startup? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.